Okay, let's build a classic snake game from scratch in Flutter. Here I have the completed game running, where I have the snake here, which is moving around, and when it consumes this fruit or the bug, it's gonna grow in its length. And when the snake head collides with its body, then the game is over. So I have the 4 buttons here to control the snake's movement, and I'm displaying the current score and the best score here. Alright, let's get started. Before we dive into the actual code, it's always a good practice to lay out the overall structure of our app first. Let's talk about the high-level UI and the widget tree structure. We will usually start with the material app class, followed by scaffold and safe area. As you can see here, we have the 3 main components: the game board, the controls, and the scores laid out in the vertical direction. So we would need a column widget with 3 children, 1 for each component. We will wrap each of the component with expanded widget to fill in the spacing, and we will use the flex values to adjust the proportions. More importantly, we also need to keep track of a game state and to be reflected on each of the UI component. In Flutter, that means we need to store the state in the column widget here or above. So it makes sense to create a new widget, say snake game, that wraps around the column and all the widget tree below. We could either make it a stateful widget and store the game state there, or we could use a provider package to maintain the state above and keep it a stateless widget. Let's go with the second route. Okay, let's tackle these UI components. The scores widget is going to be quite easy. All we need to do is to display texts and numbers. We want to make sure that the constructor takes into scores as integers, and let's get straight to writing the code. Next, let's take a look at the controls widget. This one is a bit more complex, so let's draw a widget tree. First, we want to have some padding from the top and the bottom components. Then we need 4 rounded square buttons for each direction. In order to create a square box automatically adjusted to the screen size, we need an aspect ratio widget where we set the aspect ratio as 1. Because our controls widget is under an expanded widget, we also need to wrap the aspect ratio widget inside an align widget. And finally, we need a 3x3 grid view widget where 4 of these buttons here are drawn, whereas the rest of the cells are hidden. While at it, let's complete the skeletal UI for the game board as well. It's not explicitly shown, but the board actually consists of 10 columns by 10 rows square cells. We're going to define the number of rows and columns as constants. The widget tree for game board will be essentially the same as controls widget, except we don't need the padding widget. Alright, let's get on to it. Okay, now let's dig into what we need to have in the game state. This is probably the most difficult part in creating this app. Overall, the game has 2 states. The game is playing, or the game is over. So we would need a Boolean variable, and I'm going to call it isGameOver. When the game is over, we need to display a simple text indicating that the game is over, and the user can tap on the text to restart the game. For this, we need a method to start a game, so let's call it startGame. We'd also need to display the scores here, one for the current score, another for the best score. So we need 2 integers, again call it current score and best score. We also need to keep the direction of the snake's movement, which could be either up, down, left, or right. So we need to define an enum for that. In fact, we need to keep track of 2 directions, one for the current direction and another for the direction next turn. This is because the snake cannot flip its direction 180 degrees in a single turn, so we need to keep track of the current and the next one. and see if the next one is 180 degrees flip of the current one. So let's call them current direction and next direction. For each cell of the game board, we must display one of the 5 elements: a snake head, body, tail, fruit, and finally nothing or empty. I'm going to create an array of integers where we'll draw an element from the value of this integer corresponding to each cell. I'll talk about it in more depth in a bit, but for now, we know we need an integer array or list, and I'm going to call it the cell value. We would also need a few more variables to store in the game state. Position of the snake's head is one, which I'm going to call the head pose. I also need to keep track of the snake's length, so I'm going to call it the length. Finally, this is not so obvious, but we need to keep a variable for a timer to keep track of our turn. I'll discuss this in more details later, but I'm going to call it the game loop. Now, let's think about what needs to be done when the game starts. We want to randomly place a snake. We also want to randomly place the fruit where it's not overlapping with the snake. I'm going to initiate a snake with length 2, meaning we start off with the head and the tail, no body. So I'll first randomly choose head position and then randomly select the current direction of the snake, and finally place the tail on the opposite direction. I'll also want to define a method that takes a position and direction so that it returns the neighboring position, because this is going to be useful. let's talk about our game state cell value array. Every cell is assigned with an integer value from which an appropriate widget is drawn. I define this value to be the number of preceding turns the snake will occupy this cell. For example, if the cell value of a given position is 0, then it's an empty cell because the snake is not occupying this cell. If this is 1, then this corresponds to the snake's tail, since this is the last turn the snake is occupying this cell. So if it's greater than 1, then it's occupied by the snake's body or the head. In fact, if it's equal to the length, then that's when it's occupied by the snake's head. So when the game starts, the length of the snake is 2, and we should assign the value 2 and 1 to the head position and tail position, respectively. Finally, we are going to assign the value of -1 for the fruit cell. Let's set up the game loop. I'm going to create a method called update, which will make the snake move. This method will be called periodically by the game loop timer that we set up previously. The easiest way to make the snake move is to decrease the cell value by 1 for those cells occupied by the snake. We also need to assign the new position for the head and set its cell value to the length. Don't forget to call notify listener method at the end so that Flutter updates the widgets. let's implement changing directions by the user input. We already have the current direction and next direction variables. When the user taps on one of the direction buttons in controls, we want to set next direction to the corresponding direction. We also need to set current direction to next direction during the update call. Lastly, we have to do a check to see if the next direction is the opposite direction of the current direction, because in this case, we simply have to ignore the user input. We are very close to the playable game now, although we still need some work on the UI elements for controls and game board. First, we need to add a fruit randomly. In fact, the fruit location is not a complete random location because it has to avoid those positions occupied by the snake. We also need a logic to check if the snake consumes the fruit, in which case we must lengthen our snake and regenerate the fruit. I'm going to create a method for regenerating the fruit, and implementation of the lengthening the snake is actually quite easy. We just skip decrementing the snake's cell values. Cool, the game is now quite playable, except that we do not have the collision detection. That is, when the snake's head collides with the body or tail, we need to end the game. We also need to make sure to increment the score when the fruit is consumed. Lastly, when the game ends, we must stop the game loop and set the isGameOver variable to true. Okay, we are almost done. When the game is over, we need to prompt a message to the user, and when the user taps on it, we need to restart the game. Since we are prompting the message on top of the game board, we can use the stack widget to do so. Also, when we restart the game, we need to update the best score field and set current score to 0. Now, let's fix a few more things. First, we need to listen to a tap on the Game Over widget so that we can restart the game upon the tap. We also need to change the snake cell appear as a circle rather than a square. For the tail, we need to reduce the radius of the circle. And finally, we display the head with the Android icon and the fruit with the ADB icon. Now we have a few more fine tunings to do and we're going to be done. First, we need to rotate the snake's head to match the current direction. We also need to add arrows for the controls and make the buttons rounded corners. We also need to set the game board's grid view background color to white and scaffold's background color to gray.